Hello everybody. In the last class, we discussed about the directrix, equation of directrix, in case of parabola, hyperbola, ellipse, and so on. Today, in this class, we are going to discuss about the tangents, normals, chord, equation of chord of a conic, and chord of contact of the equation of the chord of contact of the tangents drawn from a point. So we shall first discuss about the equation of chord of a conic. Equation of chord of a conic. Okay. Over here we shall consider a conic, this kind of conic. Hmm. And in this kind of conic over here we consider 2 points. One is this kind of point P, another is the point Q. Okay, this kind of point Q. Let me magnify this one first. We shall consider these 2 points P and Q, and from this point P and Q, if we join these 2 points, then this straight line, the straight line joining the points P and Q, this straight line would become the chord of the conic. And we want to compute the equation of the chord PQ. Suppose this point P has the vectorial angle alpha minus beta. This point P has the vectorial angle alpha minus beta, and this point Q has the vectorial angle alpha plus beta. Why alpha minus beta, alpha plus beta, that we shall discuss later on. You could also consider the vectorial angle to be equal to, say, theta 1. And this vectorial angle can also be considered to be is equal to another theta, suppose theta 2. Okay. And suppose the radius vector of the point P is equal to R1, and the radius vector of the point Q, that is equal to R2. Okay. Then you see, if we suppose that equation of the conic is taken in this fashion, L by R is equal to 1 plus E cos theta. If we consider the equation of the conic in this fashion, in that case, of course, these 2 points P, this point P and this point Q, these 2 points, both of these 2 points must satisfy the equation of this conic number 1. Okay. And from this observation, we are going to compute the equation of the chord PQ. All right. And we know that this PQ is actually a straight line. Therefore, equation of a straight line, we know that equation of a straight line can be written in this fashion. Over here, we used to take it as 1 by R. On the numerator, we used to consider 1 by R is equal to A cos theta plus B sin theta. Now, for the sake of simplicity of the calculation, in place of 1, we are considering small l. This is the semi-lattice rectum of the of this conic, this small l. Be very careful about it, because this is the first mistake that you generally perform in exam. Okay. So over here we consider, in place of 1, we consider L by R is equal to A cos theta plus B sin theta, where A and B, these are two unknown quantities. We need to compute the unknown quantities from the observation that P and Q. P has the coordinates r1 theta 1, and Q has the coordinates r2 comma theta 2. Okay, this kind of polar coordinates. Now from this observation, we will have to compute the values of these two quantities A and B. All right. And I am showing this calculation through another file. There I took theta 1 in place of alpha minus beta and theta 2 in place of alpha plus beta. Just for the simplicity of the calculation, because over here the computational technique is very brief. They have skipped many computational steps that I need to show you, because otherwise it would be a problem for you. So I am showing this result, just keeping this this picture over here. Let me keep this picture over here. Hmm. And you see over here, these are the 2 points P and Q having vectorial angles theta 1 and theta 2. And now in this file you observe that we want to find out the equation of the chord, joining chord of the conic L by R is equal to 1 plus e cos theta, joining the points P and the point Q, where they have vectorial angles theta 1 and theta 2 respectively, as I considered in this picture. Okay. Now you see over here, this is the equation of the chord, and we consider this same L, mind it, this same L over here, as we had this semi-lateral septum L. Got it? So L by R is equal to A cos theta plus B sin theta. Now you see this P and Q, these P and Q are the 2 points that lie on this conic having equation number 1, as well as these 2 points lie on this straight line PQ. Therefore, they must satisfy the equation of the straight line, that is actually the equation number 2. Okay. So let's first concentrate on the point P only. Let's first concentrate on the point P, and the polar coordinates of the point P are taken as r1 theta 1. Okay, the polar coordinates of the point P are taken as r1 theta 1. So you see these two coordinates r1 and theta 1, this point P must satisfy both of these two equations, equation number 1 and equation number 2, and therefore in place of r we put r1, and in place of theta we put theta 1 in both of these two equations. Okay. And after putting r1 and theta 1 in place of r and theta in equation number 1 and 2, we get this these two equations, equation number 3 and equation number 4. All right. Now from these two equations, we are trying to eliminate this r1, or in other words, we are trying to compare the left hand side of these two equations. Okay. And you see this is the reason, because of that we took L over here. Otherwise you could take 1 in place of L, then some computational disadvantage would appear. Just by taking L over here, by taking L in this equation number 2, we could easily compare this equation number 3 and equation number 4. And after comparing, we just eliminate this total left hand side, and then this expression would be is equal to this right hand side expression in equation number 3 and 4. Okay. So this was the reason because of which we took L, not 1, on the left hand side of this equation number 2. Okay. Now let's continue. Over here, you see, over here, if we eliminate R1, then we have this type of relation. This is the two sides of right hand sides of equation number 3 and 4, and we can take cos of theta 1 and sine of theta 1 on the within a same term. Then cos of theta 1 and can have this type of coefficient a minus e. Sine of theta 1 has the coefficient b, and the remaining term, that is actually the minus 1, that is kept separately. So this is the equation that we get after simplification, the equation number 5. And this is the equation that we get for the first point P with coordinates r1, theta 1. Okay, the polar coordinates are r1, theta 1. Now similarly, we can also make perform similar steps, and after similar steps we will get a similar equation, just in place of the index 1 theta 1 etc. we would get another index theta 2. Got it? We would get another index 2. So we get this similar by after similar computation we get this equation number 6. Just in place of theta 1 we have theta 2. That's all. So you see, we actually have two unknown quantities. One is this unknown quantity capital A, another is this unknown quantity capital B. We need to evaluate the values of these two unknown quantities capital A and capital B. And we already have two equations involving these two unknown quantities. Equation number 5 and equation number 6. These are the two equations involving the unknown quantities capital A and capital B. And so we can compute the values of capital A and capital B by cross multiplication. So by cross multiplication, you see, by cross multiplication we can compute, we can consider this A minus E as a variable, and this quantity B as another variable. So we put A minus E and B over here, and the remaining constant term is put over here. So I'm not showing this detailed computation. I would make this file available in the Google Classroom. You can go through the detailed computation. I'm leaving this detailed computation for you because this is actually a kind of trigonometric computation that you would generally deal in class 11 and 12. Okay. So after such manipulation, what we get this expression of capital A is equal to E plus this kind of expression. Let me magnify this one. This is the expression of capital A. Capital A is equal to cos of theta 1 plus theta 2 divided by 2 divided by cos of theta 2 minus theta 1 by 2. And what is B? B becomes is equal to sine of theta 1 minus theta 2 divided by 2 divided by cos of theta 2 minus theta 1 divided by 2. So these are the expressions of capital A and capital B that we got after this cross multiplication. So now we put these expressions of capital A and capital B in equation number 2. This was the equation number 2, that is actually the we considered this equation as the equation of this chord PQ. Okay, we considered this equation as the equation of this chord PQ. So we put this expression of capital A and capital B in this equation number 2, and what we ultimately get this type of relation, that L by R is equal to capital A cos of theta plus capital B into sine of theta. So now after simplification, you see over here this E multiplied by cos theta, that can be kept separately over here. And from the remaining terms, you see this term should be multiplied by cos theta, and then we already have this kind of term. So from both of these two terms, you see we can take this expression 1 by cos of theta 2 minus theta 1 as a common quantity. You see over here we already have this expression. So we take this expression common. This is 1 by cos of theta 2 minus theta 1 divided by 2, and the remaining terms, that is cos of theta 1 plus theta 2 by 2 is written over here, multiplied by cos of theta, and the remaining terms over here, sine of theta 1 plus theta 2 by 2 is written over here, multiplied by is sine of theta. Got it? So in this fashion we make the computation, and this E cos theta is written at last over here. And this expression cos, this total expression within bracket, this can be written as cos of theta minus theta 1 plus theta 2 divided by 2. and this 1 by cos of theta 2 minus theta 1 by 2 can be written as sec of theta 2 minus theta 1 by 2. What I generally remember about this equation is that you see theta 1 minus theta 2, that is actually the difference of these two angles. So whether it is theta 1 minus theta 2 or theta 2 minus theta 1, it doesn't matter, because a sec function is there about theta 1 minus theta 2 or theta 2 minus theta 1. So we can simply write this expression as difference by 2. Got it? Theta 2 minus theta 1, that is actually the difference of these two vectorial angles. So I am writing it as sec of difference by 2. And what is this theta 1 plus theta 2 by 2? That is actually the average value of these two vectorial angles. So I generally remember it in this way: cos of theta minus average multiplied by sec of difference by 2. Got it? This is the term that I generally try to remember it in this fashion. And this e cos theta remains same. What is the main part? You see, we started with the equation that L by R. The equation was L by R, that is equal to 1 plus E cos theta. We started with this equation. L by R is equal to 1 plus E cos of theta. And you observe, we in order to find the equation of this chord PQ, we already have this term E cos theta. That was also present in the equation of the chord, in the equation of the conic. Just in place of this constant term 1, we have this kind of expression: sec of difference by 2 cos of theta minus average. So this is the process by which we generally we can remember the equation of the chord PQ. Got it? This term 1 is to be replaced by this kind of expression, that sec of difference by 2 cos of theta minus average. That's the. And in place of this plus symbol, if we simply have this minus symbol, 1 minus e cos of theta. If we had this kind of equation of the conic, then what is the technique that we should do? You see over here, in place of plus e, we actually have minus e. Okay, in place of plus e, we have minus e. Therefore, you see there only in this e is to be replaced by minus of e or negative of e. That's all. That is the difference. L by r, if we have this kind of equation of the conic, L by r is equal to 1 minus e cos theta, then the corresponding expression over here, in place of plus symbol, we should have a minus symbol. That much modification is required. And sometimes the conic can also be written in this fashion, say theta minus gamma, in this kind of expression. If we have this kind of equation, then correspondingly, suppose in place of plus we have this plus symbol, and correspondingly over here we shall have theta minus gamma only. This is the modification that we require. Similarly, if we have minus symbol over here, then only we should have a negative symbol over here, minus of e, minus into e cos of theta minus gamma. So this much would be the corresponding modification in the equation of the chord. Okay, and as per the deduction of this book, if we consider the deduction of this book over here, in place of theta 1 and theta 2, they have taken alpha minus beta and alpha plus beta. So in this equation, you can also consider theta is equal to alpha minus theta 1 is equal to alpha minus beta, and theta 2 is equal to alpha plus beta. Then what you observe is that what would be theta 1 if this is the value of theta 1 and this is the value of theta 2. Then you see difference. What would be the difference? Theta 2 minus theta 1. Theta 2 minus theta 1. Okay, that would be actually is equal to twice of beta. Got it? Twice of beta would be the difference. Therefore, if you want to compare theta 1, theta 2 minus theta 1 divided by 2, difference by 2, that is actually nothing but the angle beta. This is the interpretation of this beta that has been covered over here, that has been considered over here. Hmm. And what is alpha? You see, theta 1 plus theta 2, if you compute theta 1 plus theta 2 divided by 2, the average value. Hmm. This theta 1 plus theta 2 divided by 2, that average value is nothing but is equal to alpha. So these two vectorial angles theta 1 and theta 2, these two vectorial angles can be considered as equal to theta alpha minus beta means average value minus difference by 2. Alpha plus beta means over here this average value plus difference by 2. So equation, the vectorial angles of P and Q can also be interpreted in this fashion. Got it? And if we consider this one as equal to theta 1 and this one as equal to theta 2, in that case, you see, ultimately, considering this formula for evaluation of the chord, we can write the equation in this fashion. You see, if we have this type of expression L by R is equal to 1 plus E cos theta, then this is the expression sec of beta by 2. Beta means difference by 2. Cos of theta minus average. Average means alpha. So this would be the equation of the conic of the chord PQ. And suppose if the equation of the conic is taken as L by R is equal to 1 minus E cos theta, then accordingly we shall have this minus symbol. That is the difference over here. So that's all about the equation of the chord. Now we are going to study the equation of the tangent to a conic. And in order to understand it in a little better sense, let us consider this picture over here. You see, suppose this is the point P and this is the point Q. Hmm? This is the point Q. We have a conic, this kind of conic, and at this point P, suppose P is the fixed point and Q is a variable point. Okay, now let me change the position of Q, keeping this point fixed. You see, if we simply consider that P, this point Q is moving towards the point P, then you observe that this is the chord, the blue line. This is the chord, the blue line. This chord is actually approaching towards this straight line, the red line. This red line, this is actually the tangent to this curve at the point P. Got it? So you see, as the point Q is approaching towards the point P along the curve, as the point Q is approaching towards the point P along the curve, this blue line is approaching to the red line. That means the chord PQ, this chord PQ will coincide with the tangent line. So we can consider that this chord, as the point Q is moving towards the point P, this chord PQ is approaching to the tangent line. So equation of the tangent line can be computed by taking the limit as q tending to the point P along the along this conic. Got it? And on which equation should we consider this limit? We should consider the limit on the equation of the chord PQ. I already discussed the equation of the chord PQ, and that in that equation we need to take the limit q tending to P. Then only the limiting status of the equation would give us the equation of the chord, equation of the tangent at the point P, this kind of tangent. Got it? So we actually have the equation of this chord PQ, and in that equation we are going to take the limit as q tending to the point P. And you see, as Q tending to the point P, as Q is tending to the point P, let me show this equation over here. You see, as the point Q tends to the point P, we can say that difference. If the point, suppose this point P had the vectorial angle theta one. Hmm, say we consider this vectorial angle is equal to theta one. This is the vectorial angle r1 theta 1 was the coordinate of the point P. So theta 1 was the vectorial angle of the point P. Similarly, vectorial angle theta 2, and that was the vectorial angle of the point Q. So as the point Q moves to the point P, we can say that this theta 2, the vectorial angle of the point Q, that should move to the point, to the vectorial angle of the point P, that is actually theta 1. So we can take the limit theta 2 converging to theta 1 in this equation. If we take the limit theta 2 converging to theta 1, theta 2 tending to theta 1, in that case you see this theta 2 minus theta 1 would be is equal to 0, and sec of 0, that is actually 1. So sec of 0, so from this factor we will have a single 1. And when theta 2 converges to theta 1, when theta 2 converges to theta 1, then the total expression would be is equal to theta 1 plus theta 1 divided by 2. So over here, in place of average, we shall only have this value theta 1. Got it? That is the equation, that would be the equation, corresponding equation of the tangent. So what would be the final expression? You see on the left hand side we have L. So on the left hand side we shall have over here, you see the corresponding equation after taking theta 2 converging to theta 1, the corresponding equation of the tangent would be L by R. L by R, that is equal to sec of difference by 2, sec of 0. Sec of 0 means 1. So 1 would appear from this factor. So we shall have 1 multiplied by cos of theta minus theta 1 plus e cos of theta. So plus e cos of theta. Got it? So forget about this one. You can forget this one. All right. Let me erase this one. And in that case, this one. And in that case, we shall have only cos of theta minus theta 1, cos of theta minus theta 1, that is as the first term, plus e cos of theta. So that would be the equation of the tangent line as theta 2 converges to theta 1. And over here you see, if we want to write the coordinates of the point, the vectorial angles of the point P and Q in this fashion, alpha minus beta and alpha plus beta, then you see when this vectorial angle converges to this vectorial angle, alpha minus beta converges to alpha plus beta, what does it mean? It means that the difference by 2, that is beta, that should tend to 0. Then only these two expressions, this expression and this expression, can become equal. So if we consider this limit beta tending to 0, then again we can get the equation of the tangent line in this fashion. You see, by taking beta tending to 0, what we get by taking beta tending to 0, the equation would be is equal to L by R cos of theta minus alpha. You see over here, from this sec of beta is equal to actually 1. Okay, so cos of theta minus alpha minus e cos of theta, this is the expression. If we have this plus symbol, then we shall have a plus sign over here, and if we consider the curve as with this minus symbol, then the corresponding equation of the tangent will have this minus sign. So whatever it is, to remember the equation of the tangent, what is the technique? the technique is that if we have this kind of curve L by R is equal to 1 plus e cos theta, then this constant term 1 is to be replaced by this kind of cos of theta minus alpha, and the remaining e plus cos theta, whether it is plus or minus, the corresponding e plus cos theta will remain same. So if we have this symbol over here, L by R is equal to this kind of equation, L by R is equal to 1 minus e cos theta, then that 1 has to be replaced by cos of theta minus alpha, and remaining minus e cos theta will be intact. In this way, you can finally compute the equation of the tangent line at the point alpha, at the point having factorial angle alpha, or simply at the point alpha. Okay, so this is the equation of tangent. Clear? Let us try to investigate the equation of normal. Suppose we have a curve like this, and somewhere at a certain point, let us draw the tangent line. Suppose this is the tangent line. This is the curve. Hmm? The curve may have this kind of equation: L by R is equal to 1 plus e cos theta plus e cos of theta. Hmm? We may have this kind of expression. Now we can draw the equation of this tangent line in this way: L by R, as we demonstrated that L by R is equal to 1. In place of 1, we shall have cos of theta minus alpha, cos of theta minus alpha, plus, because over here we have plus symbol, so plus e cos of theta. So in this fashion, we can find out the equation of tangent line. Now, what is normal line? Normal is actually a straight line exactly perpendicular to tangent. Okay. And if you recall the case of Cartesian coordinates, suppose if we have a straight line like ax plus by, this kind of straight line, plus c is equal to 0. Suppose this is the state equation of the tangent. Then how did we obtain the equation of a straight line perpendicular to this first straight line? We generally change the coefficients of x and y. B x with a negative sign minus a y, plus we adjust, we write an arbitrary constant k. And how to determine the value of k? Generally, we used to determine the value of k by considering this kind of fact that the straight line is passing through certain given point. The coordinate of that point may be known quantity. Okay, so that was the technique in Cartesian coordinates. Now, in polar coordinates, what we do, this operation, that is the change of symbols, that change in the coefficients of x and y, that is actually obtained by changing this angle theta. Hmm. By changing this angle theta by theta plus pi by 2. Okay, so we change this angle theta in the equation of tangent, and we replace this theta by theta plus pi by 2, and the constant term. What is the constant term over here? You see, when L is multiplied by cos theta or sin theta, we will get this kind of term x and y. So only constant term that we have over here is this term L. Okay. Sorry, over here this pi by 2. I deleted this pi by 2. So only constant term over here we have this L. Therefore, the equation of the normal should be considered in this way. This L is to be replaced by a constant K. So the equation of the normal should be written in this way. K by R, that would be is equal to cos of, in place of theta we shall have to write theta plus pi by 2. Okay, theta plus pi by 2 minus alpha, that is the first term, plus e cos of, over here again in place of theta we shall have to write theta plus pi by 2. Okay, so in this fashion we can model the equation of normal. Now how to obtain this constant k? So we will obtain this constant k by the fact that the the coordinates, the polar coordinates of this point P should be taken as r1 theta 1, or r1 alpha, not theta 1. Over here we have taken the coordinate as equal to alpha, so over here we have to write r1 alpha. Then you see this normal should also pass, or this equation of the normal should also be satisfied by these coordinates r1 comma alpha. So from that relation we will be able to compute the value of this constant k. Okay, so let me show this detailed computation over here. Detailed computation over here. Hmm. You see over here, over here, this theta has been replaced by theta plus pi by 2. Theta has been replaced by theta plus pi by 2. Then we shall have in place of cos of theta plus pi by 2 minus alpha, we shall have this type of expression, that cos would ultimately be equal to minus sine of theta minus alpha, and plus e cos of theta plus pi by 2 will be is equal to minus e sine theta. And now if you see r1 theta 1 is a point on this conic. This we took the equation of this conic in this fashion: L by R is equal to 1 plus e cos theta, and P was a point on this conic. So you see over here in place of R we shall write R1, and in place of theta we can write alpha over here. So in this fashion we will be able to compute the value of R1, and that R1, this value of R1 will be is equal to L by 1 plus E cos of alpha. Got it? Actually what we have, if we put L in place of R1 we have L by R1, that is equal to 1 plus E into cos of alpha. So you can see from this relation we get the expression of R1, that R1 is equal to L by 1 plus E cos alpha. So in this way we compute the expression of R1. Okay. And what is this? You see over here, this equation is satisfied by this point r1 comma alpha. So in place of r we can put r1 over here, and in place of theta we can put alpha. Got it? So if we put r is equal to r1, we will have this kind of expression. In place of the constant L, we have taken the constant L1. So L1 should be determined. Initially, I told you about the constant K, but over here I have taken in place of L, I have taken the constant as equal to L1. So L1 is to be determined. We need to determine the value of L1. Hmm. So anyway, over here we just put r is equal to r1. So we get this term L1 by r1, and if we put theta is equal to alpha, you see sine of alpha minus alpha, that will be as actually 0. Sine 0 is equal to 0, minus over here in place of theta we shall have alpha, therefore minus e sine of alpha. And just now by we already computed this value of r1, so we can put the expression of r1 over here. Over here we can put the expression of r1, and after putting the expression of r1 we get the value of L. So this is the value of L1, not L. We get the value of L1, the unknown constant L1. Okay. So if we put this value of L1 in this equation of the normal, then ultimately by simplification we get this kind of equation of normal. This is the equation of the normal to the conic. Okay. So if we have this kind of equation, what was the equation of the conic? The equation of the conic was taken as L by R is equal to 1 plus E cos theta. Hmm. So if we have plus sign over here, then we shall have plus E sine of theta. Hmm. But if the equation of the curve is taken as 1 minus E cos theta, then correspondingly we would get a minus symbol over here. Hmm. So not only minus symbol over here, we would get much more modification, because out there you see what we actually need to do, that over here if we have a minus symbol over here, what is the meaning? Meaning is that plus E is to be replaced by minus E. Got it? So plus E is to be replaced by minus E in the equation of normal. So we get the equation of the normal in this fashion over here. So plus E is to be replaced by minus E. Therefore, in place of plus E over here, we should have a negative of E, and similarly we will have a negative of E over here as well as over here. Got it? So these three modifications should be done whenever the equation of the normal is considered as L by R is equal to 1 minus E cos of theta. Okay, so that is the discussion about normal to the conic. In this way, we can compute the equation of the normal to a conic. Let's now start the chord of contact of tangents. We want to find out the equation of the chord of contact drawn from the drawn at this contact points P and Q, and the tangents are drawn from the point capital A. All right. So if we draw two tangents from the point capital A on this conic, then the contact points may be in this point P and the point Q. And suppose the vectorial angles of these 2 points are alpha minus beta and alpha plus beta. In such cases, we want to find out the equation of this chord of contact PQ. That means we want to find out the equation of this straight line PQ. Over here, we shall consider this curve. Let us consider this curve L by R is equal to 1 plus E cos of theta. Then we know that the tangent at the point P with vectorial angles alpha plus beta, this tangent would be drawn by replacing this 1 through by cos of theta minus alpha plus beta. Okay, so theta is replaced by this 1 is replaced by cos of theta minus alpha plus beta. This is the equation of the tangent at the point P. Similarly, the equation of the tangent at the point Q would be L by R is equal to E cos of theta plus cos of theta minus alpha plus beta. Let us denote them by equation number 2a and 2b. Now, you see in this point capital A, let us consider that R1 and theta 1 be the coordinates of the point capital A, the polar coordinates of the point capital A. Then the point capital A lies on both of these two tangents, the tangents at the point capital P and at the point capital Q. Okay. Over here, so we can say that this point capital A must satisfy these two equations of the tangents at the point P and Q. Therefore, we after putting R is equal to R1 and theta is equal to theta 1 in these two equations, we get that L by R is equal to E cos theta 1 plus cos of theta 1 minus alpha plus beta. Similarly, L by R1 that is equal to E cos theta 1 plus cos of theta 1 minus alpha plus beta. We get these two equations. Okay. Now we eliminate this quantity R1, the parameter, this unknown quantity R1. We are eliminating this R1, or you can say that if we compare these left hand sides, we get that these two right hand sides are equal. Hmm. And in these two right hand sides, this term e cos theta 1, this term is common. Therefore, we can compare and ultimately get that cos of this theta 1 minus alpha plus beta becomes is equal to cos of theta 1 minus alpha minus beta. Okay, so we get this kind of relation: cos of theta 1 minus alpha plus beta is equal to cos of theta 1 minus alpha minus beta. Now if we try to solve them, then we shall get this kind of result, that this first angle theta 1 minus alpha plus beta, that should be is equal to twice n pi plus minus this second angle. This second angle means theta 1 minus alpha minus beta. Now, two cases may arise. The positive sign may come over here, or the negative sign may come over here. So, firstly, for case number one, we consider a positive sign over here. You see, if we consider this kind of positive sign, then by cancelling some terms, ultimately we get that beta is equal to n pi. And you see, beta is equal to n pi is a particular value, and over here this capital A is an arbitrary point, and for any arbitrary point we can say that depending upon the position of the point capital A, the chord of contact should also be changed. And for different position of the chord of contact, we expect different values of alpha as well as beta. We expect different values of alpha as well as beta. So we cannot always get any constant value of beta. Beta is equal to n pi. This is a constant value. So it is not possible to always get this kind of constant value. Therefore, we can say that this in case number one is not useful at all. It gives us a wrong result. So we discard this case, and therefore we consider this case number two, where we consider negative symbol in this result. So we consider negative symbol, and after cancellation of different terms, we ultimately get this kind of result, that theta 1 minus alpha is equal to n pi. Okay, theta 1 minus alpha becomes is equal to n pi, or theta 1 is equal to alpha plus n pi, or we can say that alpha is equal to theta 1 minus n pi. Now you see, if we consider this type of result, alpha is equal to theta 1 minus n pi, or theta 1 is equal to alpha plus n pi, and if we use this result in equation number 3, in any of these two equation number 3, okay, we are putting this kind of result, theta minus alpha, theta 1 minus alpha. You see this theta 1 minus alpha, theta 1 minus this quantity alpha, that should be is equal to n pi. So if we use this result in this both of these two equation number 3a and 3b, okay, over here we get plus symbol, and over here we get a minus symbol. And in that case, combining these two, we can write it in this fashion: L by R1 is equal to E cos theta 1 plus cos of theta 1 minus alpha plus minus beta. And what is theta 1 minus alpha? Theta 1 minus alpha should be is equal to n pi. Theta 1 minus alpha should be is equal to n pi. So we are putting, in place of theta 1 minus alpha, we are putting n pi. Therefore, we ultimately get this cos of n pi plus minus beta, that should be is equal to minus 1 whole to the power of n multiplied by cos of plus minus beta, and cos of plus minus beta is equal to simply cos of beta. So we ultimately get this result, that L by R1, that is equal to E cos of theta 1 plus minus 1 whole to the power of n into cos of beta. And now we shift this term E cos theta 1 on the left hand side, and in that case we shall get L by R1 minus E cos theta 1, this type of result. L by R1 minus E cos theta 1, this type of result. This quantity would be is equal to minus 1 to the power of n multiplied by cos of beta. We mark this relation by equation number 4. Now we consider the equation of the chord PQ. You see, whenever we have this type of result, whenever the coordinate, the vectorial angle of this point P and the vectorial angle of this point Q, whenever the vectorial angle of P and Q are alpha minus beta and alpha plus beta in this way, then we know that the equation of the chord can be written in this way. Equation of the chord PQ that can be written in this way: L by R is equal to sec of beta multiplied by cos of theta minus alpha plus e cos of theta. And over here, if we now shift this term e cos of theta on the left hand side, what we observe, we get this type of result, that L by R minus e cos theta becomes is equal to this quantity sec of beta multiplied by cos of theta minus alpha. Now, what is alpha? You see, we already got the expression of alpha. Alpha is equal to theta 1 minus n pi. So, if we put alpha is equal to theta 1 minus n pi in this relation, where here alpha is equal to theta 1 minus n pi, then we get that this expression would be theta minus theta 1 plus n pi, and therefore this cos of theta minus theta 1 plus n pi can be written as minus 1 whole to the power of n into cos of theta minus theta 1. So let us mark it by relation number 5. Over here we call it the relation number 5. Okay, so we have two relations. This is relation number 4 and this is relation number 5. Okay, on the left we have L by R minus e cos theta in equation number 5, and on this equation we have L by R1 minus e cos of theta 1. So if we multiply this relation number 4 and relation number 5, then we get this type of expression on the left. These two factors, L by R minus e cos theta multiplied by L by R1 minus e cos theta 1. We get these two factors on the left, and on the right what we get this type of expression minus 1 whole to the power of n cos of beta. This is the expression from equation number 4, and this expression sec of beta multiplied by minus 1 to the power of n into cos of theta minus theta 1. So what we observe over here, this cos of beta and sec of beta, whenever they are multiplied with one another, then they will generate 1. This product is equal to 1. So ultimately what we actually have minus 1 whole to the power of n multiplied by minus 1 whole to the power of n. That would give us minus 1 whole to the power of twice n. And this minus 1 whole to the power of twice n is nothing but is equal to 1. Therefore, we effectively have this factor cos of theta minus theta 1 on the right hand side. So this is the factor we have on the right hand side. Therefore, this is the final expression relation in between the chord. This is the relation that we obtain from the equation of the chord of contact PQ. Okay, this chord of contact PQ, this equation has been written in a different form. So we can say that equation of the chord of contact can be written in this way. Thank you for being with me in this class.